Binary mechanics is the only theory of everything based on study of full quantization and its consequences. Binary mechanics reveals that a vacuum is not empty. Recognized particles, such as electrons and protons, account for only a small percent of the energy content of a spatial volume. And the popular gravity theories fail by omitting this missing mass. Binary mechanics provides previously unavailable technology to study vacuum content. In this study, using the Binary Mechanics Lab simulator, which is a free download at our website, we started simulations by randomly putting one states into a volume over a range of initial densities from 0 up to the maximum, where every single quanta locus had a one state deposited there to begin the simulation. Next, the simulator can be run in what I call vacuum mode, which means that any quanta leaving the simulation, going up or down, right, left, front, back, they leave the simulated volume, they're lost. So that what is happening is we're cooling down the volume. And when we finally get to a point where there are no more quanta leaving the volume for quite a long time, we determine that we're at absolute 0 Kelvin temperature. And then we look at the final density and what content we have left behind. The upper blue curve here shows the total content, including particles. If we subtract out the particles, like let's say protons, what we have is perfect vacuum. Perfect vacuum is defined as the absence of ions or atoms or molecules. And yet we see with the pink curve here that most of the energy in the volume at 0 Kelvin is taken up by the one state quanta circulating in proton and electron bit cycles. So in sum, vacuum is not empty space. And binary mechanics provides a means to study this in detail. This agrees, by the way, with concepts which are sort of vague, which physicists currently believe. For example, they believe that this perfect vacuum is a sea of virtual particles, where an electron or other particle might just pop into existence or disappear into it for that matter. And so that this technology that Binary Mechanics Lab has developed allows us to study perfect vacuum in a way that had not been possible previously. Point 4 in our summary of what's required for a successful theory of everything. Bit function analysis technology based on binary mechanics provides details of intrinsic angular momentum in the 2011 discovery of proton and electron bit cycles, which I've talked about in previous videos, and detailed accounts of motion mechanisms which provide frame-by-frame steps in all particle motion. By frame, I mean that as the binary mechanics simulator works, we can stop it at any time, and in fact there are file outputs of all the data, and look at what the state of the system is in a single frame of time, and then advance it and look at the next frame, so that physical processes can then be seen, examined, and hopefully better understood by this microscopic level of analysis. In sum, Binary Mechanics Lab software represents methodological advances. One point is calculation ability. We can produce precise values for physical measurement, whereas 20th century old-fashioned quantum mechanics can only give you a probability of an event. With binary mechanics, we can calculate exact values for displacement, which means movement, electric and color charge, vacuum energy content, etc. And vacuum studies, as I mentioned. Perfect vacuum is not empty space. Absolute vacuum definition and its energy content, including virtual particles, can be examined in detail. This technology was not available before. Zero Kelvin states allow us to define the ground state, particle definitions, ideal for light speed measurements too, because if you send a light signal, as we've done, into 0 Kelvin states, there is less interference so that we can get a better measurement of what light speed actually is. Further, parameter derivations, proton-electron mass ratio, alpha coupling constant, vacuum light speed, Coulomb's force, and etc. Laser light simulation. We can create with the simulator laser beams. In fact, any known phenomena, if the theory of binary mechanics is complete and correct, any known phenomena can be simulated. But in particular here, we can look at laser light and exactly what the configuration of M and L type energy, see there's two kinds of energy, M and L in binary mechanics, is in a laser beam. Further, the L-type quanta, in fact, appear to define the long sought after magnetic monopoles, which can be observed and studied in detail. So that bit function analysis is all of the above and more. In concluding this video, let me display this slide, which is major events in physics won by binary mechanics. I'll conclude by looking at the meaning of the phrase theory of everything. I read recently that almost every physicist has their own theory. If you think about it, that's sort of impossible. Well, it's possible that physicists will theorize and attempt to understand things, that's true, but it's only possible that there is one and only one theory of everything which is complete and correct. If a theory, like binary mechanics, is complete and correct, in fact, there can be no other one which is also complete and correct. By the way, that's why we have mathematical equations for the theory of everything in binary mechanics. There are 17 basic equations, which is in the paper Binary Mechanics Postulates. It's important to have these equations because if someone else has a competing theory, one can mathematically determine whether the two theories are in fact equivalent by looking at the math or not. But in the end, there can only be one theory of everything that is correct and complete. Is that theory the 17 equations which Binary Mechanics Lab has presented? Thanks again for dropping by. Hope to see you soon. A future video will look at exactly how we derived all of the so-called secondary constants, which your physics textbooks tell you are, in fact, quote-unquote, fundamental constants. So take care and be happy. Thank you very much.